All right, today we're going to talk about multiplying polynomials and just look at what that word says. Poly is a root that means many, and that word nomial signifies numbers. So we're just talking about expressions that have lots of different numbers and variables and exponents in it. So the textbook definition of a polynomial is an expression with a combination of terms. You'll see coefficients, variables, and constants. And here's the rule. The exponents for polynomials can't be fractions and they can't be negative. And coefficients and constants have to be real numbers. So let's break these down into some more specifics. So we've got what's called a monomial. Think the word mono means one. So a polynomial that has only one term is more specifically called a monomial. And here are some examples of monomials. Now, when you look at these visually, they look like they have a whole lot of different terms in them. And the reality is that multiplication a lot of times is deceptive because you can have so many different symbols. So here it looks like maybe we've got a term here, and a term here. But those could be rewritten where you took off the parentheses and you could take out the dot. So basically, all of that could be lumped together into one term. Same for here. Even though we see that separation, all of those could be lumped together as one term, and so it would be considered a monomial. And even that last row where you got tons of different what seems to be terms, because everything is being multiplied together, this is again only one term. So how do we multiply these? Well, we've done these before in the previous lesson. We just multiply numerical bases as always. So if we were to simplify this, we'd multiply 6 times 1/3 like we always have, 6 over 1 times 1 over 3. And then we would take the like base parts, and since we're multiplying powers, we would add the exponents. So we would end up with y to the 8th, and here with, oops, that's a z, not an x. So the x and the z can't be combined at all. So we would just apply laws of exponents. Now, let's look at these that are not monomials. I want you to look at first column versus second column. Notice what I've introduced. I've introduced addition, or second example, I've introduced both addition and subtraction, and third, again, addition and subtraction, and the fourth one, I've introduced also some addition and subtraction. When you see terms that are added or subtracted, that's when we say there are separate terms. So let's just talk about how many terms we're dealing with here. For that first example, 12x to the 4th plus y to the 8th, the distinction between the two terms would be right there. How many terms do we have? It's 2, and there is a specific name for a polynomial with 2 terms, and you can think about like something that has 2 wheels is called a bicycle. So something that has 2 terms is called a binomial. So for that second example, again, let's look at our separation between terms. We're looking at those addition and subtraction signs. So there's a separation here, and there's a separation here. So how many terms do we have? We have 3 total terms. And again, think about something that has 3 wheels is called a trinomial or tricycle. So something that has 3 terms, or polynomial with 3 terms, is a trinomial. For that third one, again, our separations are those addition and subtraction signs. How many terms are we looking at? Again, we have 3 terms, so this is also a trinomial. And then finally, for that last example, here's our separation of terms. How many terms do we have? We have 4 total terms. And this doesn't really have a specific name. Anything above 3 is just called a 4-term polynomial. If it had 10 terms, it would be a 10-term polynomial. But do definitely be familiar with the terms binomial and trinomial, because I'll use that embedded in questions really regularly. All right, here's the deal. As soon as you introduce expressions that have more than one term, so as soon as you introduce a binomial or a trinomial or a 4-term polynomial or something with even more, you have to keep in mind that in order to multiply, you're going to have to do some distribution. So don't forget that you've got to distribute. So let's do some examples here. So first off, I want you to look at what we're dealing with for this first one. Here, what we have is a monomial right here times a binomial. As soon as you have even one binomial, trinomial, or more, you've got to think distribution. So what does that look like? We have to multiply 2x times the 5x squared and also 2x times the 3x. Now, for each step in distribution, you're still going to use the same rules that you did before, where we're multiplying numerical bases like we always have, and we're adding exponents on variables, on powers. So here, if we say 2x times 5x squared, remember this is an x to the first, so we would end up with 2 times 5 is 10 like it's always been, and x to the first times x squared is x to the third. And then we've got 2x times 3x. 2 times 3 is 6, just like it's always been. And x to the first times x to the first is x to the second. And now we have our binomial, or our polynomial simplified into one final binomial. Okay, example 2, I want you to notice it's extremely similar to example 1. All I've done is I've replaced the addition sign in the parentheses with a multiplication sign. It's really important that you know how that changes your strategy. This is actually one big kind of messy looking monomial. So there's no distribution to be done here. We're just going to simplify. So we're going to multiply again, like think about this. I could rewrite this as 2x times 5x squared times 3x. And then I could even rewrite it again, and I can put all the numbers in front and say this is 2 times 5 times 3 times x squared times x. And now 2 times 3 times 5, so 2 times 5 is 10, 10 times 3 is 30, and then these are x to the first times x to the second times x to the first gives us x to the fourth. So notice no distribution here. I just multiplied things together that I could multiply together. All right, now we're going to talk about binomials times binomials like this. Notice I've got two terms right here. Here's one term, here's the second, and I've got two terms right here. Here's one term in the second. As soon as we introduce any sort of polynomial into the mix, we have to distribute. So here's the deal. Your concept is everything in the first parentheses has to be multiplied by everything in the second parentheses. So you've got to multiply 3x times 5x and 3x times negative 1. And then you've got to multiply 2 times 5x and 2 times negative 1. And if you make sure that every term in the first parentheses gets multiplied by every term in the second parentheses, then you're in good shape. Now, I'm going to give you two really popular strategies that can help you when you're multiplying polynomials. So the two strategies are FOIL and the box method. So FOIL, here's the key, and be careful. FOIL really will only work when you're doing a binomial times a binomial, and it just helps make sure that you're not missing any step in the distribution. So let's talk about what that acronym means. The F stands for that the first thing you're going to do is multiply the first term in the first parentheses times the first term in the second parentheses. The O, you're going to next multiply the outside terms in both parentheses together. The I stands for inside. That means you're going to multiply the two inside terms together. And then L stands for last, and that's where you're going to multiply the two last terms in the parentheses together. So the other method is a box method, and this can be adjusted. If you had, for example, a binomial times a trinomial, instead of making a 2 by 2 box, you could do a 2 by 3 box. So this can be scaled up or down however you need to. But here's the key. You're going to put the binomials on the sides of the boxes, and then for that top left box, you're going to multiply the first column and first row. And then for that bottom left box, you're going to multiply the first column times the second row. And then for this top right, you're going to multiply the second column times the first row. And for the bottom right, you're going to multiply the second column times the second row. So it's kind of like a genetics Punnett square. So you've seen those before, and it's the same strategy. So we're going to do FOIL for this first example, and then we'll do the box method for the second. So FOIL, we're going to do first times first. So we're multiplying 3x times 5x, and that gives us 15x squared. Now we're going to do the outside. So the outside terms are 3x and negative 1. So 3x times negative 1, that gives us a negative 3x. The I is the inside terms. These are our inside terms right here. So we're going to multiply 2 times 5x to get 10x. And finally, we're going to multiply the last terms in the parentheses. So 2 times negative 1, and 2 times negative 1 is negative 2. Now be careful, look right here. Those are like terms. So we can combine them. We can say negative 3x plus 10x is equal to 7x. So then your final polynomial after we simplified is going to end up being a trinomial. Your first term is 15x squared. The second term is the result of combining these two terms, so it's going to be plus 7x, and then your third term is negative 2, and now you have multiplied that entirely. All right, we're going to go on to the next one, and this one we're going to do using the box method. Notice we have a binomial times a binomial. That means two terms times two terms, so when we draw our box, it's going to be a 2 by 2 box. So on the top, I'm going to put an x and a plus 2. So we're just separating out the terms. On the side, I'm going to put a 3x and a negative 4. So top left box, we're going to multiply 3x times x to get 3x squared. The top right box, we're going to multiply 3x times 2 to get 6x. The bottom left box, we're going to multiply x times negative 4 to get negative 4x. And then the bottom right box, we're going to multiply negative 4 times 2 to get negative 8. And again, just like that previous example, I want you to notice we've got like terms right here. Those like terms can be combined. So we end up with, I'll go ahead and write the full polynomial first. So we have 3x squared plus 6x minus 4x minus 8. And then these two can be combined to get a final answer, which is a trinomial of 3x squared plus 2x minus 8. All right, so the next couple of examples are places where students make a ton of super common careless errors. Now, you've seen questions that look similar to this, and what you would do is just apply the 2, or you apply the square to the x and apply the square to the 5. You cannot do that unless this is a multiplication. So here, I'm going to give you a little sidebar. You cannot just apply the 2. We have to distribute. So I want you to think about what this means. It's the binomial x plus 5 squared. When I square something, I multiply it times itself. So now this is really what we're doing. So we have a binomial times a binomial. So we can FOIL it or do the box method. So I'm going to multiply first times first and get x squared. I'm going to multiply outside times outside and get plus 5x. I'm going to multiply inside times inside and also get plus 5x. And then I'm going to multiply last times last and get 25. Finally, we can combine those two middle terms and get a final trinomial of x squared plus 10x plus 25. So be very, very careful on those. Don't just apply the square to the two terms. You have to expand it out and then FOIL or use box method. Now, I want you to look at this one. See what's different here. There is no addition. This is just one monomial. So here we can just apply the square. So if you're dealing with only a monomial, we can square the 2, we can square the x, and we can square the 3, and that's fine. So we can say that this is 4x squared times 9, and then multiply 4 times 9 to get 36x squared. And this is okay because we're dealing with a monomial. Another way we could have gone about that is we could have simplified inside the parentheses first and done 2x times 3 to get 6x, and then squared 6x. Again, this is still a monomial, so we can just apply the square to everything. So 6 squared is 36, and x squared is x squared. But notice the difference. These are both very similar, but now instead of a multiplication, I have a subtraction. If I have something other than a monomial, I have to distribute. So again, I cannot just apply the square to all the terms. I have to expand it out and then FOIL or box method. So let's do that. So we have 2x minus 3 times itself. Now I'll do a box method again. Since we're dealing with a binomial times a binomial, we'll do a 2 by 2 box. Now the top box is 2x times 2x, so 4x squared. The second box, the top right, is 2x times negative 3, so negative 6x. The bottom left box is 2x times negative 3, so also negative 6x. And then the bottom right, negative 3 times negative 3 is positive 9. And again, notice, we have like terms that can be combined. So we started off with 4x squared minus 6x plus 9. But these two can be combined, so we have a final answer that's a trinomial of 4x squared minus 12x plus 9. And you're done.